Okay, this part of the lesson, we're going to take a look at word problems and write the equation and graph it. We're also going to talk about how we have realistic limitations or restrictions that we'll put on the domain and range. Professor Watson has 12 students pre-registered. The registration closes after 7 days. During registration, the class averages about 2 students per day. Write the equation with constraints to model the situation. So we start with 12 students pre-registration. So let's look at our graph. Our X values represent the days, and the output, our Y values, represent the students. So depending on how many days pass will tell us how many students are enrolled in Professor Watson's class. Now this is during registration, but prior to registration, pre-registration, she already has 12 students. So we're going to write our equation y, which is going to represent the total number of students. It's always good to identify what the x and y stand for, total number of students. Okay, so our y-axis is students. X is going to represent the days. So each day during registration, it's going to increase by 2. And like we said, we already have 12 to begin with. So on day 0, I have 12 students. On day 1, 2 times 1 plus 12 is 14, and so forth. So now let's go ahead and graph this. Then we'll talk about the domain and the range and restricting those values. Because realistically, you can't have negative students, and registration does close, so you can only have a limited amount, up to 7 days. So we're going to start out on day 0, we have 12 students. And then you can see my increments. This is day 1, day 2, day 3, 4, 5, 6, and 7. And we know we're going to cut off at day 7. So I'm just going to sketch in this vertical line. So my days is going to be from day 0 to day 7. That's the only X values that are allowed. So we can write this in interval form from 0 to 7. You may also see it as an inequality. So X being my days can be from 0 up to 7. Okay, and then we'll talk about our students in just a second. You can see the least amount of students is going to be 12. So if on average each day it goes up by 2, I'm just going to go ahead and let's plug in some values. So at day 2, 2 times 2 is 4, and 4 plus 12 is 16. So on day 2, I have about 16 students. And let's see about what this would be. From 12 to 18 is 6. And so in the middle of 6, that would be 3. So this would be 15. So that can kind of give me a clue. So these in between, these are going up by 3s. So always notice your intervals. And then this would be 27. So making sure 12, 15, 18, 20, yes, by 3s. So we plugged in 2 and we got out 16. So on day 2, there's about 16. So I'm going to put that about right here. And then let's do day 4. 2 times 4 is 8 plus 12 is 20. So on day 4, there's about 20, or there are 20. And then let's go ahead and do day 7, the end here. So 2 times 7 is 14, and then 14 plus 12 is 26. So here is our graph. I'm not going to put arrows on the ends. So from 12 students, and we set up to 26 students would be the range. Oh, I wrote 16. That should be 26. Excuse me. Let's correct that. And I just want to double check my math. So on day 7, 2 times 7 is 14 plus 12 does give me the 26. So that's the maximum amount of students in this class. The least is 12. Now notice on this inequality I used y because that represents our output. So on day 5 it asks how many students are in the class. So on day 5, 2 times 5 is 10, and then 10 plus 12 is 22. So on day 5, we have 22 students. So I'm going to write that as an ordered pair, not an interval, an ordered pair. Jude's bathtub contains 40 gallons of water when filled to the top. The water drains at a rate of 5 gallons per minute. Write the equation with constraints to model the situation. So the bathtub starts out with 5 gallons of water. So let's look at our axis. So X is going to represent minutes. And our Y value is going to be, and Y is pretty much always a total amount of water in the tub. Not what's drained, but in the tub. That makes a difference. Because we start out with 40. We're going to start out with 40 gallons of water. So Y, my total amount of water in the tub at 0 minutes, okay, is going to be 40. So it's going to be draining. So draining means negative. So 5 gallons per minute. So at minute 0, I have 40 gallons. Okay, so our domain is going to be from 0, or excuse me, it's going to start out at 40, and then it's going to go until it drains completely to 0. But, excuse me, minutes is going to be our domain. Remember, we have to be realistic. We can't have negative minutes, and it's not going to drain forever. It's eventually going to empty, so there is restrictions. The water, how much is in the tub, is going to be the range. And we'll talk about that in just a minute. So let's go ahead and graph this. So we start out, we have 40 gallons of water. That might be a really large bathtub. Wowzer. Okay, anyhow, so let's go ahead and I like to see in between, this is going to be 35. This will help us with our graphing, 25, 15, and 5. And here we have minutes, 1 minute apart. Okay, so let's just go ahead and do 2 minutes. So in 2 minutes, we have negative 5 times 2 is negative 10, plus 40 is 30. And then in 4 minutes, negative 5 times 4 is negative 20, plus 40 is 20. So we can see it's going down at a constant rate of change. So here's our nice graph. The domain, our X values, is minutes. So the least amount of minutes it's going to be draining is 0. And then it's going to drain until 8 minutes, and then there's nothing in there. So we can write this both ways. Range is how much water is in the tub, but I'm going to write it numerically. So it's going to be from 0 up to 40. This is my range from 0 to 40. And we can write that as an inequality as well. It says how many gallons remain after 3.5 minutes. So let's plug this in. Negative 5 times 3.5 plus 40. Let's use our calculator. And we have 3.5 times negative 5 gives me 17.5. And then when I add that to the 40, that's 22.5. So in 3.5 minutes, I have 22.5 gallons. The Kinsey Tree Farm planted 2 feet Douglas fir trees. So the trees are going to start out at 2 feet tall. After 1 year, the trees were about 3.5 feet tall. The trees continue to grow at this rate until they reach 8 feet when they are cut for Christmas trees. So they started out at 2, and then in a year they grew to 3.5, which is 1.5 feet. So they're saying that at each year they're going to continue to grow 1.5 feet. So that's going to be our constant rate of change each year. And there's going to be a limit on how tall they get, which is 8 feet. So that's going to help us with our range. So let's write our equation. First of all, X is going to be years. Each year it grows 1.5 feet. The Y value is going to be the total height of the tree. So my equation is Y equals the total height is going to be 1.5 times each year that it grows plus what it starts out to be at 2 feet. So let's graph this. So these are going up by intervals of or increments of 3. So they start out at 0 years, they start out 2 feet tall. Now, let's go ahead and see, because in 8 years they're going to be cut and it's going to stop. So let's see how tall they are in 8 years. And that's the question actually down here. So I'm going to say 1.5 times 8. So the 100% is 8, and half of that is 4. So that is 8 plus 4 is 12, plus 2 gives me 14. So in 8 years, they're going to be 14 feet tall. So in 8 years, they're going to be 14 feet tall. So 8 is my X, which is years, and 14 is my height, which is the Y. This is an ordered pair. So we can just let's just do one more point in between. And let's just pick 4. So when I plug in 4, I'm just going to use my calculator right quick. So 1.5 times 4 plus the 2 is 8. So in 4 years, the trees will be about 8 feet. And so let's just connect these dots as nicely as we can. We're going to stop because there is a starting and a stopping point. So my domain is in years. So in 0 years, they will grow until they're 8 years, and then they get cut for our holiday trees. And then the range is how tall, what's the least height they are, and that is the 2 feet that they start when they're planted. And then at 8 years, they are 14 feet. So an inequality would be 2 is greater or less than my Y, my height, which is greater or less than 8. So during that time, excuse me, this should not be 8. Sometimes when I'm talking, my brain shuts off. Trying to multitask here. Okay, so 14. So the height is somewhere between 2 and 14 feet, depending on the time of year that they have been growing. Brooke is having a skating party for her birthday. Her parents are allowing her to invite 12 friends along with 6 members of her family, including Brooke. Skate City charges $50 for the parties, plus $5 for each guest. Write the equation and constraints to model this situation. So here's where we're going to write the equation. The total amount, so my Y value is the total amount that the Skate City charges, total amount charged. The Y value, it depends on how much we pay, depends on how many guests we have. So the X value is number of guests. So my equation is Y equals, we have to pay $5 per guest plus the 50 upfront charge. So With 0 people, I still have to pay the $50 up front. So these are going up by 20s. And these are going up by 3s. And we already kind of know our limitation of how many guests. She's going to have 12 friends plus 6 members of her family. So that's 18 people. So the number of guests is going to be from 0 to 18 people. And then my charge, the least amount of the charge is going to be 50. And then we'll calculate, then we'll calculate how much it's going to cost if all 18 people attend the party. We'll get that in just a second. So let's go ahead and plot this. With 0 guests, it's $50. Let's go ahead and get the maximum amount. Let's get the maximum amount, and then we'll answer that bottom question. So it's 5 times the 18 people plus the 50 is 140. So with our 18 guests, it's $140 right here. Now let's answer this. How much does it cost for Brooke and her friends? So just the friends. So 12 friends plus Brooke, that's 13. So 5 times 13 plus the 50 gives me 115. So 13 friends is 115. That's about right here. So with 13 people, that's her 12 friends plus her, it's going to cost 115. And our maximum amount we said was 140. So the total amount of cost, Y, is somewhere between 50 with 0 guests and 140 with all 18 guests.